And welcome to today's webinar, Secure SD-WAN Architecture, Genuine Multi-Tenancy. Before we begin, there are a few housekeeping items to keep in mind. If you have any questions during today's webinar, please enter those questions at any time in the Ask a Question box below. We will monitor these questions throughout our webinar and answer them at the end of the webinar. You can also download the slides from today's broadcast along with the white paper, Genuine Multi-Tenancy, at any time by clicking on the Attachments tab. This webinar is being recorded and will be available to view on demand following today's live broadcast. Now let's get started. My name is Michael Wood, CMO with Versa Networks. I'm joined today by Neil Danilowicz, Principal Architect with Versa Networks. Welcome to the live broadcast, Neil, and thank you for leading today's discussion.
Thank you, Mike, and welcome to everyone who's joined to talk about this important topic. Today we're focused on genuine multi-tenancy and what that means for a secure SD-WAN architecture. Now, in the times that we live with the increased effort to work from home and deal with unsecure networks such as internet, obviously security and segmentation are at the forefront. And a lot of people will talk about segmentation and the reasons for why you might want to have segmentation or multi-tenancy. And these reasons come from business models, like you might have multiple different business units inside the company, and so you might want to keep separation from that. Obviously, many of the companies are not organically grown from a single company. There's mergers and acquisitions that end up putting in segmentations. Oftentimes there may be regulatory requirements such as credit card industry or HIPAA requirements. Security being the first and foremost, obviously we want to protect our customers' information as well as the intellectual property of the individual companies. And then just obviously risk management and failure domains, right? We want to make sure that we can segment the network and have impacts to parts of the networks that we know are going to fail, but not have a total outage across the entire enterprise. So for these reasons, right, we know that segmentation and multi-tenancy becomes an important architecture and use case to help provide scalability and stability to the enterprise. Now, traditionally, we have dealt with multi-tenancy models or segmentation models by using like layer 2 bridge domains, whether that be discrete layer 2 segments or whether it's virtual LAN segments riding over a layer 2 network or a layer 1 network. Or obviously in the routing domains, you could get into different things like VRFs, different VPN or virtual private networks. Zone concept, right, to be able to segment your network that way. Encryption methods are a way of actually segmenting traffic in a manner to actually make sure that one part of the network doesn't necessarily know what the other part of the network is doing. Even down to micro-segmentation, which SD-WAN really takes one step further to being able to segment applications, users, whatnot into different types of traffic. But all of these have an inherent problem when it comes to actually working with this traditional way. And most of it can be boiled down to basically shared resource or shared access. At a layer 2, if I have a switch and I just have two segments that are separated by a firewall, meaning that traffic needing to go from one layer 2 segment to the other layer 2 segment has to go through a firewall to allow that access, I can, if I have a shared resource and I have access to that shared resource through my part of the network, I can actually get into that device and capture traffic from the other side of the firewall. So shared access becomes one of the biggest problems, and it permeates from layer 2, layer 3, all the way down to micro-segmentation, where I'm running the same network, but I'm just using different tags and policies to actually distinguish my traffic throughout the network. So this just clearly, this label here clearly just defines this, the ability here of being able to look at that shared resource and maybe have access to the green side, but then do a traffic capture because you can get into the user switch or the router on the other side. And a truly multi-tenant set. Go ahead.
Yeah, it sounds like there's a lot of different methodologies that can be used for, for, I guess, multi-tenancy, if you will. But almost what you're describing here is, any one of these things on their own isn't substantial enough to actually create a genuine multi-tenant, model. And there are obviously a lot of different definitions in terms of multi-tenancy. Sometimes, segmentation is referred to as multi-tenancy, and other capabilities that might not be a complete model. Are there different are there other types of definitions that you've seen out there that people use for multi-tenancy?
Yeah, as we look at this, it really has to start at almost like a pervasive set, and you can look at multi-tenancy at each layer of the onion or each layer of the network, if you will, and you can talk about it. Right? There's a lot of SD-WAN vendors out there that offer a multi-tenant orchestrator or management layer that you can then look at individual pieces and people won't see what other tenants have, right? So so there are many layers, and we'll get into a lot of those layers as we go forward, right? So in this set, we have a true shared set where I have two VLANs, everybody's using the same switch, we're using the same access. So in that traditional sense, I get segmentation at the VLAN level, but if I can get into the switch, I still have some exposure. If we look at what a true multi-tenant might look like, you would partition each of the devices into a way that the individual tenants wouldn't be able to see the other resources. And that would be whether it's at the aggregation layer or whether it's down at the branch layer or whether it's in the management layer. And it includes the ability to use different transports and even be able to do different overlays. So one of the things that we look at in a genuine multi-tenancy is that at the management plane, you literally have this set. So you go into the orchestration layer, a tenant gets his role-based access defined for him. He's only allowed to see his workflows. He's only allowed to see his devices. He's only allowed to see his statistics from that layer. And that's really good, and a lot of people have looked at this as, well, this is kind of service provider level stuff. I'm an enterprise. Why do I need, this multi-tenancy? But as we all know, in enterprises today, and in a lot of enterprises today, you have development environments, you have regulatory arenas, right? Like payment card industry or HIPAA or federal, right? And they need to be segmented out. And you need to have controls and security around those, right? We have zones that we want to expose to the internet, right? Back in the day, it was very easy to consider yourself not part of the rest of the world. You'd create your network, and then you just wouldn't connect to anybody. You came to enclose, and then e-commerce came about, and it was very important to actually connect to the internet, right? So you could do this commerce and integrate with everybody else, and so now you had to do, security based upon just that e-commerce part. But now we're talking about just access from everywhere, right? So you want your employees to have access from everywhere, especially in the day that we're living today, where majority of the people are working from home. We need to be able to have this ubiquitous access anywhere. And so this puts this segmentation or multi-tenancy into a very forefront and thoughtful idea. So as we look
now,
at
Neil,
what
you've managed a lot of networks and have overseen quite a few different implementations and topologies. Is there an example? A couple of slides ago, you showed what really makes up a multi-tenant model, where you've got tenants, you have subtenants, you have multiple transport, connection options. You even have different topologies. You had different topologies in that diagram. Is there an example of you don't necessarily have to give the name, of the enterprise or business, but maybe the type or vertical that company was in that uses that type of a multi-tenant model, which again there are a lot of different things included in there: tenants, subtenants, and topologies, and all those things. Any examples that come to mind?
So clearly, obviously, in the financial scape, we see this a lot, right? And that's kind of, as we built the slides here to kind of drive this home, we're using the model of some sort of financial institution that has an ATM network, has the banking and the banking teller network. You could have an infrastructure to do security investment, and you break them up, and you don't necessarily want one side or the other side to be able to influence the other. And so by creating this multi-tenancy, you actually are able to give resources and policy control and management to the individual business unit. And even to that one business unit, they might have sub-business units under it. Think of a technology company that wants to have, they've got their support side, they've got their engineering side, and then they've got their development side, right? And in the development side, they might have labs that they want to have in there, and they want to make sure that they have the security models set around for the labs to allow that to work. But they don't want it to influence what actually happens in the development side where they house the labs. And they definitely don't want development to encroach upon the support or the product delivery side. So there are a lot of different models in which this works. A true multi-tenancy is not going to just give you one layer. You're going to have at least a few layers deep so that you can actually build this flexibility into it. And as we go into the control plane side, it's very important that we look at how we separate out the management side, the control plane side, and the data plane side. Because if we don't do that, one of those planes might influence the other. So in a true multi-tenant set, your management is going to have different connections, different encryption types, different authentication types and methods to actually be able to allow the business units to do what they need to do, and then control the different workflows that they need to do. And then in the control plane, the exact same thing is going to happen, where everybody's going to get their encrypted control plane connections, and that's going to be housed and transported separately than the actual data plane, because we're going to keep the data plane out of that path. And this way you get separate keys, separate transport protocols, all that type of stuff, different topologies.
Now, Neil, you talked a bit about security earlier on, and I'm just wondering, one of the other key aspects here is, the idea of having different even groups or roles within the business. You talked a bit about the tenancy model and subtenants and groups and things like that, but talk to us a bit about sort of the importance around having different roles. And I'm thinking the one that comes to mind is the one that you refer to as maybe the SecOps and the NetOps teams, and maybe even different individuals within each of those teams. What are some of the requirements in a multi-tenant model that you've seen in your experience from that breakdown?
So in the multi-tenant model, typically you'll have a top tenant, which a lot of people will look at, sort of like the CIO level or the CISO level, where they're going to talk about global policies across the board. And this really permeates whether it's security, policy, design. Literally at each one of the tenant levels, you get to be able to define what you want to do, but because it's hierarchical and structured, you actually are able to put global security parameters or global business policy parameters around the subtenants below it. So it really works well in both being able to apply, say, regional compliance. EMEA and GDPR is a really good example, right, where you can actually have a layer in between and you can institute this GDPR set, and that it's going to permeate across your company for that area where it needs to be. Or it could be simply a global security policy that you want to apply, but not necessarily restricting all the policies that might need to be applied at a lower level that are become a little bit more restrictive, right? So the true multi-tenant architecture allows that to happen, and because the role-based access puts you into a tenant that reduces the scope of what you can see and what you can control, you can have global governance on top, but yet individual governance of the individual business unit or part of the business unit that they need to work at. And that permeates whether it's the NOC, the SOC, customer help desk, or just engineering in general, right? Finance could be another example. But now we're talking about just taking it from a policy point of view. You can extend this all the way down to an application point of view, where in different parts of your business unit, you might treat different applications differently. So like on the call center side, voice might be your highest priority that you want to do, whereas in your or in your retail side, perhaps point of sale is your most highly prized application, and so you would end up giving it a policy that would take priority, maybe even say over voice. But this doesn't just permeate from the point of security, network design type, business model type, even down to applications. It also permeates all the way down into the individual box itself, because what we know about multi-tenancy is literally your weakest link of shared resource determines how well your multi-tenant model works. So if I'm on a device that has a shared CPU and I have no way of allocating that CPU between my tenants, then I can, in that model, you would allow basically one tenant to possibly take up all the CPU in that device and thus adversely impact the other side. So we're going to take multi-tenant. Yes, go ahead.
You brought something up there where and I want to maybe drill down into it, which is this idea that you mentioned there, where maybe I've got two different interfaces being used, and I feel like I would think, wow, that's definitely multi-tenant there because it's completely separated. But what you're describing is that you said something like, I think the weakest link. There's another resource that maybe isn't being thought of, isn't top of mind, that could actually cause this issue. Have you seen that in practical experience at all? Again, based on all the networks that you've designed and overseen?
So I actually was in part of a root cause analysis for a very major failure, where the issue came down to that the individual interfaces were actually rate limited. And they were rate limited to what would seem to be a fairly reasonable set. The problem was that the interface rate limit actually exceeded the CPU capabilities. So it was theoretically a proper design. The interface had a rate limit. The CPU had a rate limit. However, someone, I don't know who, but someone in the design didn't realize that the rate limits that they applied, the CPU couldn't handle even the rate limit that the individual interface could actually provide. And so at that point, what ended up happening is you literally overran the CPU. And so this is where we get into, if you don't have a way of carving up the resources, and that can be CPU, it could be memory, it could be disk space. I mean, I'm sure a lot of people have heard of failures because one process just happens to write up the temporary disk space and goes to 100%, and then all of a sudden everything crashes, right? You need to be able to have the ability to carve up your system in a way down to the most minute detail, if possible, right? That it's not going to affect.
In that model, then, those could have been obviously two separate tenants on a same physical device, two separate interfaces, and maybe not intentionally, but one of those tenants, literally floods the network and creates an issue for the other tenant because of the CPU overutilization, or hard disk drive, like you said, or memory, or whatever it might be, whatever resource that is. So that's interesting. sounds like that's a requirement then, is to be able to provide that type of separation, even back to the CPU and protecting resources and things like that.
That is definitely true. Well, I mean, one of the things that you look at when you look at true multi-tenancy is you want the complete flexibility to allow the tenant to do what he's authorized to do in a manner that does not step on anybody else's toes. And to be truly effective, you want your multi-tenancy to be able to be flexible enough to deal with failure domain scenarios, meaning, I don't necessarily have to bring all my transports into one device. I don't necessarily have to have all of my logic in one part of the network. I can have many different iterations of these and still help with keeping my network to be resilient by having failures, individual failures, but being able to have enough redundancy to actually work around that. And so as we work through this, we need to make sure that a genuine multi-tenant design also takes care of all the different levels, right? We talked about it. You want multi-tenant management. You want multi-tenant control. You want multi-tenant data plane. You want multi-tenant data plane at the branch. You want multi-tenant data plane at the aggregation point, whether that's your hub, whether that's just, some sort of aggregation point that you have in the middle of your network, whether that's your private data center, whether that's private cloud. And theoretically, you would even want a true multi-tenant cloud offering, right? Because if your cloud or your SaaS isn't multi-tenant and you have all these tenants going and accessing that one SaaS or cloud provider, and that cloud provider gets overrun, now you're affecting all your tenants, right? So this is the idea that you really have to look at it globally, and you want that flexibility in the platform to actually allow you to be able to do this. A lot of people ask me, so when you say multi-tenant and it has all this flexibility, does that mean that you can separate your routing domains? Does that mean you can separate your layer 2? Does that mean you can separate your policies? Does that mean you can separate your access controls, your encryption, your keys, your certificates? And in the end, I look at them and say yes, because if you can get your truly multi-tenant design in a way that is that flexible, then it allows the business unit to decide what's important to them, what aspects do they want to control. Now, clearly trying to get to the utopia where you support everything, so we talked about, routing protocols, do we support DECNEC, AppleTalk, IPX, do you support ISIS, do you support, IP, all the other things, BGP, OSPF, MPLS, right? Clearly, vendors and service providers and managed service providers, they're all going to have limitations. And so that's what makes the space really interesting, is because not everybody is going to be able to be the jack of all trades. And so you're going to have people who are going to define their different roots and different places where they're good at. But the key is to look for that flexibility. Go ahead.
You mentioned something that was interesting, which is this, it's a clear trend that's happening, is the more greater adoption of cloud and cloud services and SaaS. So that is one thing that, I think for me, I didn't really realize, didn't really think about it, that the idea of extending multi-tenancy, not just on premises and to everything, within the offices and the data center and the campus, but also having that extension back into the cloud. And so, it sounds like maybe what you're saying is that that's not something that you would normally get. You don't get a multi-tenant model necessarily when you activate all these cloud services. You need to really have that multi-tenancy extended from the enterprise back into the cloud. Is that a requirement that you're seeing from businesses and enterprises?
That is a requirement that we're seeing. You're seeing a lot of people in cloud services. They'll make different cloud sets, and then they'll want to know how how I can build my redundancy, how I can do my interop, right? Because a lot of companies are sitting there saying, hey, I don't want to put everything in one cloud service provider. I want to be able to put part of it in this cloud service provider, maybe a redundant copy in a different service provider, right? So this way, if that cloud is having a problem, I can go to the other cloud. And right now, there's not a lot of true interop between them. And this is where the SD-WAN space, the SD-WAN service providers, managed service providers, and vendors are sort of stepping in and saying, hey, we can help you with this. But now doing that multi-tenancy allows you to attach different types of cloud offerings. You know, like for AWS, you might have different VPCs, right, connected for different tenants, and then allow that to work between them. And so you can actually work that way. So while your cloud service provider might not be fully tenant, you might be able to attach to a SD-WAN vendor or an SD-WAN service provider that does offer multi-tenancy and start to get to that. So as we look into what really multi-tenancy can do to us from, I'm going to focus on kind of the security aspect and the secure access service edge, but this could permeate into you know, how you would deal with cloud and how you would deal with other type of SaaS services. But if we go in and look at just traditional service functions for, you know, a legacy multi-tenant, typically we had discrete functions handled by discrete companies, right? And so it ended up giving us almost a serial processing where I would have to hand off to this and then hand off to that and hand off to that. But when I go into a multi-tenant set, that means I have to have multiple firewalls. I have to have multiple antivirus. I have to have multiple IPS. I have to have all this other instantiation if I don't want to have that, quote, shared resource. Obviously, in this model, I could mix and match. If one of my security functions was actually multi-tenant, I could actually use the same instance, but that would also require not only that my function was multi-tenant, but my actual secure access service edge was multi-tenant. If we look at what you can do in a true, genuine multi-tenant secure access, what you get is the service secure access service edge itself is multi-tenant. And then you start to layer on top multi-tenant functions. You end up getting this ability to have almost a single lookup, because the device can come in and say, here's my packet, here's all the attributes, and start handing them off in parallel to all the different devices. And each one of my tenants could use all of the functions, or I could use a subset of those functions, but I wouldn't necessarily have to have more than one copy of each function. Obviously, to meet scale, right, as I have more and more tenants, I might not be able to put them all through a single function, or I might have redundancy, so I have multiple copies of the function, but I'm reducing the number of functions that I actually have to replicate. And this model, again, could still be hybrid. Some of it could be done this way, and I could still hand off to a security SaaS provider, right, where I go out and they do maybe the antivirus or they do the IPS. It could be I have to hand off to do my proxy service, or I have to hand off to do a mail service app. But the model still fits.
And Neil, this architecture, just on the security side that you show here, obviously mirrors the secure SD-WAN architecture overall, which is this, you know, concept of being able to operate on, to really deliver multiple functions simultaneously in almost a pipelined, you know, model. And so what you're saying here is that a genuine multi-tenant secure SD-WAN and secure access service edge, this is the way that that's implemented. It leverages that idea of being able to process things simultaneously, but does so in a multi-tenant manner so that I get the complete separation, versus a previous slide that you showed where oftentimes I've got to have either separate appliances or separate even software instances or virtual network functions that are running to be able to get that multi-tenant model. When you look at security, Neil, have you seen where there's requirements even within security? So maybe I've got a SecOps team, but being able to bifurcate and maybe separate different functions within the SecOps team that need to be able to configure, and set different policies for different tenants or different application types and things like that. Does that exist, and how does this genuine multi-tenant architecture address that?
So it's a very good set in that. In a lot of enterprises, you have your security side, and they're putting all the security rules together, and they're doing all that type of stuff. And then you have your network side, which is doing your layer 2 policies and your QoS and your routing decisions and things like that. And then you have governance, which comes in and says what you can do on this and that. And in a true multi-tenant set, we can still have things compartmentalized where you have that ability for security to do what they need and look at their appliances, how they want to see it. But at the same time, to allow for role-based access control that says, maybe security doesn't need to modify routing, but maybe security needs to understand routing and understand the design so they can actually get in, look at that, and maybe utilize some of those things, right? As we talk about this and the ability to actually compartmentalize and use certain things, you get this idea of reusability, right? Certain things start to become building blocks, right? So the overall company will decide the actual access policies and behaviors that are required for each one of their organizations. But what we wanted to do is start to take and make things reusable. I think everybody who's in the industry will understand when I say that you write QoS policies and you sit there and you do your application based upon a set of IPs, based upon a set of ports, source and destination IPs, source and destination ports, so source and the protocol that goes with it. And then what ends up happening? The guy in the firewall says, well, this needs to go out to the internet. And so he turns around, he writes, okay, I need source and destination IPs, and I need source and destination ports, and a protocol. And wouldn't it be nice in a multi-tenant environment where you could just say, hey, this now becomes a building block. And because of the roles and responsibilities and the way that it works, wouldn't it be nice to just say, hey, security, as network writes a rule, you can go and use it, right? And that really makes it a true, adaptable and functional, genuine multi-tenancy, right? We even talk about, when we look at the previous slide, some of the sets inside of SD-WAN is, people would look at this and say, well, I take the firewall and I know that I'm either going to permit or deny the traffic before I hand it off to URL. So why doesn't URL filtering just accept that the traffic coming to me has already been scrubbed and is already permitted? And when you start to talk about zero trust models, everybody starts to pick this apart, and they're like, well, what if somebody compromises the first guy or can trick the first guy, right? And then it passes through. So you get this idea that no one wants to sort of share the common set. And so that's another one of these things that you don't necessarily get if you don't have everything living within the same work frame or structure, right? So
the same software stack, right?
Exactly. And obviously you want to look for software stacks or solutions that, especially when we get to this side, it's really nice here to have this single provider or single security vendor giving me all of this stuff. But we know the following: it's very difficult for everybody to be best at everything. So you want to be able to have that ability to do what that individual security vendor wants, but also have the ability to plug and play in your stuff. And whether that can be plugged and play inside and be parallel processed or be the next, serial thing in the chain, that's up to, kind of the business unit and the integration. But I point this out because this becomes a real use case as 5G really becomes a reality, right? The idea today is for a secure access service edge, if you could have your thick client where everything is done at that edge. The problem comes in is how much compute are you going to associate to doing that edge? Because let's face it, antivirus and IPS are very compute intensive, right? Especially if you want to do it quickly and not cause a huge increase in latency or delay in delivering the packet. But if I get this network, and this is the vision of 5G, that is low latent, high bandwidth, and has access to almost infinite compute, then what I might be able to do is take a thin down client that might have my next gen firewall, might have my secure proxy in it, but then I take some of the URL filtering, the AV, the IPS, the data link protection, the deep packet inspection, all that type of stuff, and then move it to the cloud, right? So I'm going to do all my malware and do it all there because I have high speed compute. That that model works very well if you have that flexible structure, and I want to be able to do it per tenant. I don't want to do it just for the whole network because maybe one tenant really doesn't need to follow that path. Maybe one tenant really does need to have the thick client there, right? So you want that flexibility.
So it's that SASE model where, as you've described, like there's a slider between the branch office, for example, and the cloud. I can have the heavy branch like you discussed, and the light cloud or light branch and heavy cloud or anything in between. But I think the nuance here that you're hitting on is that it's also got to leverage a genuine multi-tenancy architecture to be successful. Now, Neil, I do want to go back, and if you don't mind, there's one display that you showed, which is this one, which is really all about genuine multi-tenancy operating across all these planes. And I was wondering if you could go into maybe a little more detail on the management plane, the data plane, and the control plane, and why having multi-tenancy across each one of these is really so important, and how this genuine multi-tenant architecture delivers across each one of these, if you don't mind.
No, so it's really important that, again, we're trying not to have that shared resource. So when it comes to the management plane and I'm looking at my statistics and I'm doing my lifecycle management, whether it's code upgrades, whether it's instantiating new flows, whether it's bringing devices online, offline, that type of stuff, it's really important that you're scoped to what the tenant really needs, right? And maybe even the subtenant, right? So you might have an engineering group that's allowed to do all this stuff, but I want to restrict what my lab side could do or what my beta testing side can do, all that type of stuff, right? You really want to have that type of control from a management side. And by having the overarching hierarchy, I can impose, global templates, if you will, into what each one can and cannot do. When it comes to the control plane side is something that we necessarily want to segregate out, right? Back in the day, you always had this issue of, well, how much of network control or layer 2 control do I really have to put into my enterprise network? Because clearly, if I can't keep the network up, the fact that, my data doesn't get through, I need all this control to keep the network up so the data will get through. But I want to make sure I want to segment this now to the different tenants, because I don't want, a control statement from one tenant to actually cause impact on the other tenant, right? So this is why it's very important. And this gets into even down to certificates, encryption keys, all that type of stuff, the ways that you might reflect routing updates, from a reflector client, whether or not you use, what type of control plane protocols you're even using, right? And then in the data plane, it's extremely important. As we know, there's always shared resources. The networks that we traverse are shared. It's how we actually partition those shared networks in a manner where we restrict each tenant from having the full scope. So, to give an example, if I have an ISP in which I'm doing all this connectivity over and I'm doing multi-tenancy, well, then I would set up mechanisms so that, no single tenant could actually use the full ISP bandwidth. This also goes to, we're talking about security and what can the person capture traffic on that interface? Well, let's just say for argument's sake that the person had access to one tenant, he had access and he knew his certificates and his keys for that tenant, and somehow he was actually able to get access to capture all the traffic coming out that interface. In a true genuinely multi-tenant implementation, I would use different certificates and different encryption methods and keys across all my tenants. So even though I was able to capture that set, I wouldn't necessarily have all the key ingredients to actually, be able to decrypt and utilize the other tenants. Now, a true multi-tenant design, a genuine multi-tenant design, wouldn't allow for this accidental. I mean, you're talking about more of someone gained physical access or tapping access to the actual service itself. But from the actual, inside the actual service, you wouldn't be able to do that because your role-based access control and your multi-tenancy would not allow you to see another port. So example is if I'm on a switch that's got 24 ports on it and only 5 ports, and let's just say those 5 ports are 17 through 21, that's all I see. I see 17 through 21. I know that there's at least 21 ports on this switch because, I'm logical and I know that someone wouldn't start at 17 and go to 21, but I don't know which tenant has port 1. I don't even know how port 1 is configured, right? I see what I see and I get access to that. So that helps, segment this in a way that it really helps you control the impact from one tenant to the other.
Now, Neil, one of the things that you called out here, and you also showed it in one of the previous slides, is this concept of independent topologies. And so I'm thinking of maybe a retailer with maybe a couple of cellular phone companies inside the retailer that are, that are maybe partners, and maybe a help desk, kind of a technical support area, or maybe, like you said, financial services, where I've got wealth management, I've got retail banking, maybe I have a brokerage, or maybe even healthcare, where I've got healthcare equipment on one network and doctors and nurses communicating on another network. But having different topologies that you show here in the control plane, does that mean that a genuine multi-tenant architecture allows me to, say have a mesh topology along with the hub and spoke topology, all using the same physical equipment and even the same software stack in all the devices? And how would you do that with a genuine multi-tenant architecture?
So you're spot on. So in genuine multi-tenancy, each tenant can define the type of topology they want. But with the work that's being done with MEF and certifications for the SD-WAN, we're actually taking it even further than that, to where we can allow each tenant to define virtual topologies for applications inside their tenant. So I'll give you an example. In the retail space, a lot of people will have the telephone system, and it's quite common that you might have to call from one store to another store to check on, customer comes in and it's not available at that store. Hey, can I pick up and call the other store and see if it's available over there? And you send the customer over so they can pick it up, right? So in a voice application inside that, even inside that one tenant, you might say, hey, for my voice application, I want a full mesh. I want everybody to be able to call everybody, right? But for my point of sale, it's not common that your point of sale would actually reach over and actually talk to another point of sale terminal at another store. So maybe for your point of sale application, you actually have a more hub and spoke model where the point of sale terminal only talks to the point of sale server, right? So you can actually get down to that level. But to your point, each individual tenant can actually define their own topologies, what their default topology is, what their individual application topologies are, right? So, it gets down to that level. And that's just one example. You can do that with security policies. You can do that with all kinds of different attributes, whether that's even microsegmentation. Microsegmentation and looking at applications differently inside a single tenant is still supported. And each one of your tenants could actually do them completely differently.
That's fantastic. Neil, maybe, do you think you can summarize? I know it's probably not that easy, but to go through that genuine multi-tenancy architecture for secure SD-WAN and what are some of the key takeaways, I guess?
The key takeaways is segmentation and microsegmentation are all good and well, and they all serve a purpose, but they don't necessarily always get you to your end goal. And your end goal is to have parts of your network and even individual devices in individual business units that will not and cannot step on all the others. So a true multi-tenancy will take you to that level. You want to make sure that this is pervasive across all your planes, your management, your control, your data plane. You want to make sure that it's extremely flexible, and you can see the list of stuff here. We don't want to necessarily have a single NAT pool that we have to go to. We don't want to worry about our keys. We don't want to worry about, hey, everybody has to use the same role-based access, right? You want to be able to allow your multi-tenants to do what you do. Now, that does not mean to say that you don't have role-based access here, control, where you sit there and say, overall, you have to do it this way, or you have to use these set of servers, but you want to make it flexible. Multi-tenancy needs to be at every level of the network. Access, aggregation, data center, cloud, private cloud, it needs to be there. Because the key here is multi-tenancy is only as strong as your weakest link. Think of it as just like a chain. If I have a shared resource and it gets overrun and all my tenants are dependent upon that resource, well, guess what? Everybody's going to be affected, right? And, you want a multi-tenancy that allows for multiple levels. So this way it'll transcend whatever the business structure is and be able to marry into that business structure, right?
That's fantastic. Yeah, and certainly within each level, as you've said, having the ability to support different use cases and business models, and even compliance requirements might be different between different tenants, even within the same enterprise, and certainly security profiles are different too. One thing that I think is interesting is that, and this is a question that has come in also, is around the next-gen firewall. So is it, I guess, Neil, is it possible, when I think of a secure SD-WAN architecture, the attributes there are a comprehensive integrated security, scalable advanced routing, full-featured SD-WAN, sophisticated analytics, and then, of course, multi-tenancy. When I look at the security piece, do I need to have have to have separate next-gen firewall instances to be able to have a multi-tenant firewall as part of that? How does that work? To be able to get all these things. Again, I'm thinking like, a dozen different tenants. Do they all share the same firewall, and how's that even possible?
So again, it really comes down to your actual security provider. So if your security provider ends up having a truly multi-tenant architecture for their security function, then no, you don't have to have multiple different next-gen firewalls. Now, obviously, scale and throughput and all of that come into play, right? So you have to take that into the grain of salt. You may have to have multiples to be able to support that, but that means you'd be able to still put multiple tenants through a given one. Now, if your security function is not multi-tenant, then it becomes a shared resource when you put two multi-tenants through one. And then, again, it goes back to the same thing that we talked about. Shared resources can be your weakest link, right? So if you don't want shared resources and your security function is not genuinely multi-tenant, then what you end up with is multiple instances of that security function. Whether that's, like we said, dedicated or shared becomes the problem.
Thanks, Neil. So folks, we've got a lot of questions that have come in so far. Please keep them coming, and we'll answer as many of them or all of them if we can as possible. So Neil, actually, the first question here is related to what you just addressed. So the question is, does the Versa Next-Gen firewall, does it support this multi-tenancy?
Yes. So Versa Next-Gen firewall is fully multi-tenant compliant, and it actually has 5 levels of multi-tenancy, as the whole Versa offering does. So we allow 5 different levels of multi-tenancy. And then, obviously scale comes into it. The more levels of multi-tenancy you get into, the larger the configuration and processing gets. So, scale goes along with that. But yes, we are multi-tenant.
And we learned at on a previous webinar, the secure SD-WAN architecture allows one to actually dramatically increase the scale just by adding more processing and more cores and things like that. So next question, Neil, is can another tenant see the physical interface of, can one tenant see the physical interface of another tenant if it is not using the port?
So the answer to that is no. If that tenant doesn't have access to that interface because it's assigned to another tenant, then no. You can't see it. You can't see the config. You can't even see the traffic. And in a properly designed multi-tenant vendor, right, so into the device, even on the shared port, if I'm looking at my transport port, I only see that which is mine, right? So if I have that port going to the ISP and I'm sending 50 megabits of traffic, I see 50 megabits of traffic. The fact that the ISP is seeing 500 megabits of traffic doesn't matter. I look at that interface and all I see is 50 megabits of traffic.
Fantastic. Okay. And some of these we've answered. The next question is, what policies can be separated, security or routing?
So I love this one because a lot of people talk to me about this when they talk about traffic steering and whatnot. So in a multi-tenancy, it really comes down to how flexible the multi-tenant design is. But a proper one, it should be basically, you should be able to say yes. So do you want to do a separation of QoS policy? Do you want to separate your traffic steering? Do you want to separate your routing? Do you want to separate your security? Do you want to separate your workflows? Realistically, the answer should be yes. And, I can do all of that.
Okay. Fantastic. That makes complete sense. So, okay, this is a good one. How do you, how does a secure SD-WAN architecture with genuine multi-tenancy, basically, how do you protect CPU, memory, and storage if it's all in the same box?
So there are multiple ways, especially when it comes to CPU, memory, and storage. I mean, you can do allocations where you actually carve it up and you allocate only certain regions to be used for those. That becomes a little bit problematic when you want to deal with, spiking and burstiness. A lot of times you'll get a time-based or share-based allocation method so that no one person can go over it. If you're a true software implementation and you have the ability to throw more cores to the actual processes, you could actually start to dedicate certain CPUs to certain tenants. Again, if you're going to go that way, you get some limitations with how far you can scale that, and also what you do with when a CPU isn't being utilized. But there are many different methods in which you can go in to restricting what a individual tenant can do on the CPUs themselves.
Okay, and then there's continuing a few more security questions. So this question is, how is authentication and key exchange handled with multi-tenancy? I know you mentioned some of that. Maybe a little more detail on that.
So in the situation of having to do authentication and key exchange, you would definitely have in each individual tenant the ability to point to the appropriate authentication clearinghouse the ability to have different mechanisms for the actual encryption keys, the length, the protocols used, the ciphers and the reference architecture, as well as differencing in ways in which, you know, the length of the key is allowed to be active, right? The life cycle of the key or the certificate. And these would be carried over discrete channels. So this way you don't have to worry about, hey, I got one channel and someone just happens to capture that whole channel and does that. And hopefully you have an advanced security type set where, and this doesn't really have to do with multi-tenancy, but hopefully you find a solution where full key exchange is not put on the wire, right? You would want something where keys are derived or partially exchanged, right? This way, no one has the full keys to the kingdom, so that if that device happens to get compromised, it provides the necessary means to break into the network.
Excellent. Thanks, Neil. Another question around security is, can I meet PCI compliance standards using multi-tenancy, you know, using this genuine multi-tenants model? Is there a way to you know, kind of get, I guess, to PCI compliance to that?
So this is one of the greatest use cases for multi-tenancy, is by taking into your business unit where you have, you know, that level. So you take your overall company, you break them into business units, and then you make a subtenant of that business unit that is PCI. You actually get to control what goes into it. You have all the security controls around it. Nothing else is in there. And then because you have the full control on how tenants actually get to talk to each other, right? Because you're controlling that access, you actually then get to prove to your compliance officer or the auditor that it is completely segregated. No one can look at it unless they're actually allowed to look at it, and you can go into your role-based access control and display that.
Okay, that's great news. Another question here, and I think this was in one of the slides that you shared, was what does the reflector client do? I think that was in an earlier slide.
So reflector client is something, you know, we try not to just use for routing protocols these days, right? There are many mechanisms where you can actually reflect information back and forth. So this could be state information. It could be, in the case of an HA, where you need to have that, and so you're going to reflect the traffic back. It could be key information, right, that can actually be shared back and forth so that people know what the keys that are needed to be able to talk to who or what. But again, anytime that you have that type of mechanism in a truly multi-tenant, you want to be able to have it so that each tenant would have its reflector and its reflector client, right? So I wouldn't want to have just one great big reflector system and all my tenants sent to that one guy, again, shared resource. You'd want to have that ability to actually break those up into a single instance for each of the tenant or subtenant.
Okay, that's fantastic. And then we have time for one more question, which is, can you support different routing protocols over the same interface? I think it means probably same physical interface.
So the answer is to that is yes. Realizing that these devices are in themselves at the location, no one wants to necessarily put out a router, you know, multiple routers because they have multiple business units at the site. We want to do this collapse of devices into each other. So that means that on the interface leaving that device that's heading out towards the rest of the network, we have to be able to support multiple different routing protocols. And we need to be able to support that on the different tenants, because there may be different use cases or different types of routing protocols or different topologies and security functions.
Okay, fantastic. Any other questions that we didn't get to, we'll reply to you with answers via email. Again, I want to remind folks that this webinar has been recorded. It'll be available on demand following today's broadcast, and you can download the slides in the attachment tabs along with a white paper on genuine multi-tenancy. Neil, thank you very much for taking time to cover this this interesting topic and for your presentation today.
Mike, thank you for asking me to be here, and I hope people got a lot out of this, because this is something I truly believe in, and I think it's something that the industry needs to continue to work towards.